Okay, so we're going to be taking notes on the page that you received in class today. This is based on the second fundamental theorem of calculus, and there's some free response questions related to that. You'll most of the time on these kinds of problems you'll be given a graph, and in this problem you need to keep in mind that this function is f of x. And it tells us in the problem that g of x is the integral of f of x. So on A, it wants us to find g of 2, g of 4, g of negative 2. So if I'm looking at what g is, which is what it tells me up here, I'm just going to plug in the 2 for x, and then the 4 for x, and then the negative 2 for x. So g of 2 would be the integral from 1 to 2 of f of t. And then the integral, I come over here to the picture, there's 1, there's 2. I'm trying to find this area. And it looks like we have 2 triangles. No, it's hard to see that. 2 will intersect it right there. So there's this triangle up here, and then that rectangle if you want to do it that way. And then you find that area. So the triangle would be 1/2 times 1 times 2. And then the rectangle would be 1 times 1. So g of 2 is going to be 2. Alright, g of 4 means the integral from 1 to 4 of f of t. So I need this part from 1 to 2, which we already found out was 2. But then I also want this little next part, because I'm going to go all the way to 4. You'll notice that those two parts cancel. So it's also going to be 2, but it's 2 plus a half minus a half, if you want to do it that way. And then g of negative 2 would be from 1 to negative 2 of f of t. Now, 1 to negative 2 is backwards than what we normally look at, but that's okay. First of all, let's just find out what the area is going to be. So here's 1, and here's negative 2. Basically, we just have that triangle. So it's 1/2 times 1, 2, 3 times the height, which is 3. And you get 9 halves there. Now, the trick on this one is since these two numbers are backwards, we talked about this a long time ago, but if the numbers are backwards, you change the sign of what you get. So your actual answer is negative 9 halves. Okay. So B says find g prime of 0 and find g prime of 3. Alright, we know up there, the original problem, that g of x is the integral from 1, I'm actually going to write this somewhere else. G of x is the integral from 1 to x of f of t. If I want to find the derivative, we're going to do what we did on yesterday's video with the second fundamental theorem. I'm finding the derivative of the integral. I'm just plugging the x in, so I get f of x. That means that the derivative of g is f of x. And then if I want to find g double prime, well, that would be the derivative of f, so that would be f prime. So going back to the problem, if I want to find g prime of 0, g prime of 0 is f of 0. And since this graph is f of x, I just want to know the y value, and I get 2. G prime of 3 would be f of 3. So I just want the y value at 3, and I get 0. G double prime of 0 means f prime of 0. So it means the slope at 0. So count the slope, do rise over run. It's 3 over 3, so you get 1. And then G double prime of 1 means f prime of 1. So I want the slope at 1. And it's undefined because that's a sharp point. So we use this graph to do an integral in A. We used it to find the y values for B for the G primes. And we used it to find the slopes for G double prime. Alright, C. C says find the instantaneous rate of change of G with respect to X at 2. Alright. Instantaneous rate of change means the derivative. It's asking you what's the derivative of G at 2. We already found out that the derivative of G is f, so it really just wants to know f of 2. And I go and get the y value. F of 2 is 1. Alright, D. Find the absolute maximum of G on the interval from -2 to 4. Alright. Normally when we try to find the maximum or minimums, we find the derivative, set it equal to 0, and then find our values. Okay? Well, the derivative of G is f. We've already figured that out. And we know that f of x equals 0 at three. And what that means is that there's a max at 3 since f of x changes positive to negative. Now, since when we're looking at our endpoints here, they're from -2 to 4, and they don't actually have the brackets on them, then we're looking just for the maximum between -2 and 4. So since 3 is the only maximum, then x equals 3 is the value of the maximum. Now the question actually said find the absolute maximum. So that means although x equals 3 is where the maximum is located, it means to figure out what g of 3 is. So I'll go back to my original equation. G of 3, I just plug in 3 for x, and it wants to know the area from 1 to 3. And we did 1 to 2 earlier. We got 2. And then from 2 to 3, it's that little rectangle. So we're doing up here 1 to 3. And we found out that was 2. And so I do that little triangle there, 1/2 times 1 times 1. And so 2 plus 1/2. So you get 5 halves, and that's the actual absolute maximum. Alright, the second derivative of g is not defined at x equals 1 and x equals 2. Which of these values are coordinates of the point of inflection of the graph of g? Okay, let's go back up to our picture a second. Alright, it's talking about the second derivative of g, and we already figured out that when we're talking about the second derivative, we're talking about f prime of x. So if we're wanting to know the points of inflection of g, the points of inflection of g is where the second derivative is 0 undefined and changes sign. So they're telling me that the second derivative is undefined at 1 and at 2. Oops, 2 is here, I'm sorry. And that makes sense because there's sharp points there. Now, the question is there a point of inflection at either 1 or 2? And the answer, what has to happen is that the second derivative has to change sign. Okay, this is f of x, which is really the first derivative of g. The second derivative of g, as I'm thinking about the slope of this graph. And the slope of this graph is positive and then negative around 1. And then around 2, it's negative and then negative. So what that means is there's a POI at x equals 1. Since f prime of x, or you could say g double prime of x, changes positive to negative. No POI at 2 since f prime of x doesn't change sign because the derivative, the slope, is not changing at that point. These particular problems are all very, very similar. Like you think about the area, you think about the slope, you think about the y value. And so we'll just continue practicing and we'll do one more problem like it. Okay. They tell me here that this graph is the graph of f. And then they tell me over here that g is the integral from 1 to x of f of t. So let's get this straight in our mind again. G is the original. G prime of x is the derivative of the integral. Again, the second fundamental theorem. So g prime of x would be f of x. G double prime of x would be the derivative of f. So the graph that's given to us is really the derivative of g. Alright, I'm going to leave some of these in A for you to do, but I'll remind you a couple of them. So let's do one of each. Let's do g of 1, g prime of negative 3, and g double prime of negative 1. I want you to do those other ones. Okay? So g of 1 means that I plug 1 into the equation where they tell me what g is. So I just put a 1 in there for x. And that means to find the area between 1 and 1. Normally on the graph you would start at 1 and you would go wherever the value is, but since it's just the same value, then you're just going to get 0 because there's no area between there and there. When you do g of 3 and g of negative 1, you're finding those areas. And keep in mind that's a circle and then a triangle there, and do it those ways. Okay, let's do g prime of negative 3. Okay, come back over here. We've already figured out that g prime is f. So really that just means f of negative 3. And f of negative 3 just means the y value. So that's also 0. Alright, and then let's do g double prime of negative 1. We've already figured out that g double prime is f prime. So f prime of negative 1 means the slope at negative 1. That would be up here at the very top of the circle. And we know that that slope is 0. Alright, you go back and do g of 3, g of negative 1, g prime of 2, and g double prime of 3. Do those on your separate sheet of paper. Alright, B. I'm going to erase this so that I can write on the graph. B says, on what intervals of x is g decreasing? Alright, g decreasing means where G prime is negative. Well, G prime is F, so I want to know where F is negative. And this goes back to that big chart thing that you've got to memorize or think about. So F is negative, or below the x-axis from there to there. So that would be from 1 to 3. And justifying, that's all those things that I just wrote, where I'm thinking about it in my mind, and I'm writing it down. That's the justification. G is decreasing, where G prime of x is negative. That means F is negative, and that's from 1 to 3. Alright, C. Find all the values of x on the open interval from -3 to 4, where G has a relative minimum. Okay, so we're looking on this graph from -3 to 4, which is the old graph, and we're looking for a minimum. Remember that the graph that's given to us is the derivative of G. So if I'm looking for a minimum, I'm looking for where the derivative changes from negative to positive, which would be right there. So there's a minimum at x equals 3. Because f prime of x changes negative to positive. And you know what? That wasn't an f prime, that's just f of x. Or if I want to call it g of x, I could. It's g prime of x, because really that graph is g prime, which is also f. I'm sorry. It doesn't ask you to find the minimum, it just says find where the x values are a minimum. So you just need the x value. D says find the actual maximum value and then find the x. So it wants the x and it actually wants how big it actually is. Alright, so the maximum is going to occur where the derivative changes positive to negative. Remember that this graph is the derivative. So it goes from positive to negative above to below the x-axis at 1. And so g prime of x is f of x. So there's a max at x equals 1. Since or because g prime of x changes positive to negative. To find the actual value, that means figure out what g of 1 is. And we already figured out g of 1 up there at the top when we did number 1. And g of 1 was 0. And 0, that means is the actual absolute max. Alright, E wants to know where G is concave up. So G is concave up where G double prime is positive. And out to the side, we already know that G double prime is f of prime. So really I want to know where f prime is positive. Alright, the graph that I have is f. If I want to know where its derivative is positive, then I'm thinking about positive slopes. So positive slopes would occur there and there. Everywhere else is negative. So f prime is positive from -3 to -1, and also 1 to, or actually 2, I'm sorry. That starts there at 2, and then 4. You wouldn't go to infinity because the graph just stops at 4 according to this particular one. For what values does G have an inflection point? Well, if you know where concavity changes, then that's where the inflection points are going to be. Since we know that it's concave, that G is concave up at those red places, then I know that there's going to be a point of inflection there and there, because the graph will be concave down in between there. So there's an inflection point at x equals -1 and x equals 2 because g double prime changes sign. You could say that f prime of x changes sign if you wanted to, or you could say because concavity changes at those two places, concavity of g. Last but not least is the g part. It wants us to write an equation for the tangent line at g at x equals -1. Alright, if I'm trying to write a tangent line, then I need to know, I'm going to write it all over up here. I need to know an x, I need to know a y, and I need to know a slope. I know the x. Okay, the y value would be g of -1. And it's whatever that you got. When you tried that problem, I'm going to go ahead and tell you that you should get -pi for that. If you didn't, we can talk about it, but you should get -pi for g of -1. And then the slope would be the derivative of g of -1, which means that's what the f of -1 is, because we know that g prime is f. F of -1 is just the y value, and you get 2. And then now you have all the information you need to write the tangent line. So if you do y equals mx plus b, add your 2 over, so your b is going to be -pi plus 2, which means your equation is y equals the slope x and then plus the b. And you can find that decimal or you can just leave it. Most of the time these particular questions are without a calculator.